Oops, I didn't check my camera. It's not even on. Please hold. There I am. All right. So today, we are going to talk about um, factoring polynomials. And I'll tell you what that means. And as you can see, we're covering a lot of lessons here. And the reason, once again, I did this with the previous chapter. It's because in those 6, 7, 8, I don't know how many that is. I guess it's 8 different lessons. They teach you 8 different ways of factoring, which all apply to very specific cases, very specific shortcuts. So I'm just going to teach you the overall method. That way you don't have to worry about learning 8 little things. You can worry about learning the one thing that works all the time. So this will all be beneficial to you. Um, so yeah. Okay, let's start by multiplying some binomials together. Remember, binomial means there's two. So multiply a binomial by a binomial, and we'll get a new trinomial, meaning there's 3 terms. Um, so if we FOIL all of these, I'll show you what we go ahead and get. So here we see that after we FOIL, we get trinomials from all these binomials, okay? So and these things are equal, just like if we had 6 times 7 equals 42. These are just two different ways of writing the same thing. You just may want to write it one way over another depending on the situation. So let's actually see what these things look like graphed. So we're going to go to Desmos. So if we look here, you see I have our original 2 binomials being graphed, and I also have the final product trinomial being graphed. And as you can see, they're right on top of each other. So there are 2 ways of writing the same thing. Now, what we have here is a parabola, and a parabola is just that loopy thing. We get parabolas whenever we have an equation that has an x squared term as the leading as the highest exponent. So whenever the highest exponent is 2, that's when you'll see a parabola here. All right, so yep, you see it just does its little dip. Now, if you look, there's special points where it crosses the x-axis. Just like when we graph a normal line, like y equals 3x plus 2, there's a special point where it crosses one of our axes. This positive 2 here, you can see right here. So in a similar way, where we cross our x-axis, we can actually see this in the original equation. Now, you can't see it in the trinomial form. We don't see where that -2 and that 7 come up. But if we look in the factored form, when we have our 2 binomials, you can actually see that. We have a -2 that corresponds to this +2, and we have this 7 correspond to this -7. So you can see we have the 2 and the 7, the signs are just flipped. And the reason why is because let's look. It says this is our coordinate, it's x, y. So if our x is -2, let's plug it in. If x is -2, -2 plus 2 is going to equal 0, which means the whole thing's going to equal 0, which is why we have -2, 0. And let's take a look at 7. If we plug in 7, 7 minus 7 is 0, and if we multiply everything by 0, that's going to give us 0, which is why we have 7, 0. So the point of all this is if we graph a trinomial, we have what we call roots, which is where it crosses the x-axis, and those correspond to the x values if you factor it out. Okay, so in a way, if we have this right here, we know to put 2 dots on the x-axis and then just draw a parabola in between it. There's a little more be a little more specific, but that's the general idea. So usually it's a better idea to turn our trinomials into 2 binomials. That way we get some more information out of the situation. So that's what we're going to teach you to do in this lesson. We're going to figure out a way without graphing to find these 2 values. Now let's go ahead and look at these other examples. So we already know what the trinomials look like for these. Here we have x minus 3, x minus 4. If we were to graph these, where do you think they would cross the x-axis? they would cross at 3 and 4 because the question you want to ask is what value of x will make this binomial 0? So if x is 3, 3 minus 3 is 0. If x is 4, 4 minus 4 is 0. So that means we're going to have a parabola with its intersections right over here. So let's graph it, and there it is. We have one intersecting there and one intersecting there, 3, 4. What about this one? It's going to cross at -3 and -5 because we're flipping the signs. -3, -5. Okay, we got a parabola. And then lastly, it's going to be a 5 and a -2, -2 and a 5. Okay, so this is a graphical description of what's going on, but the main focus of this lesson is turning our trinomials and factoring them, because that's exactly what we're doing. Because factoring is just what two things multiply together to get this trinomial. So it's just like the factor trees we've done before, except this time we're going to need a different tool. Now, like I said, the book dedicates 8 lessons, 7.3 to 7.10, to giving different ways for this factoring method, depending on the situation. But what I want to do is I want to give you the better way, the more general way to do it, because that'll help you solve all the problems and you don't have to remember specific situations. So it's the difference between having a bunch of little wrenches. Each of these are useful because they fit a specific size, but you also need to carry around a ton of wrenches. And if you lose one of those wrenches or you forget how to use one of those wrenches, you won't be able to unscrew your bolt. But if you have one of these wrenches, you only have to carry one around and it adjusts to whatever you're working with. So I would much rather give you one of these tools to help you with polynomials as opposed to filling your pockets with these, because then your pants will fall down under the too much of the weight. So it's a little bigger than the others, but it's better to use and used in more situations. So that's the end of that analogy. Let me jump right into it. Okay, so this is the trinomial. Oh, can you see that? Something just popped up on my screen. Okay, so this is the trinomial we were working with a second ago. So we'll use this as our example. And the key of a polynomial is that it has an x squared term, an x term, and a term without an x. Okay, so it's got 3 parts, right? And that's why we call it a trinomial, because there's 3. And as a general rule, if we want to write a trinomial, it's going to be a coefficient on the x squared term plus a coefficient on the x term plus some third term without an x term. Okay, so this is just a general description of a trinomial where we know we have the x squared, the x, and the no x, but each of these are just going to have a different coefficient. In this case, our coefficient is 1. In this case, our coefficient is -5. And in this case, we just have a -14, right? So we could say the coefficient on the first term is 1, the coefficient on the second term is -5, and the coefficient on the third is -14, right? These letters are just representing the coefficient, okay? So A says, I'll type it up. So you can just think of each letter asking a different question. A says, what's the coefficient on x squared? B says, what's the coefficient on x? And C says, what's the constant term? Constant just means there's no variable. Okay, so this is the first part of factoring. The first part of factoring is recognizing what coefficients we're working at. Step 2 is knowing the formula or knowing the tool we're going to use. And this is the formula. And I'm going to write it out. And you don't have to understand why it works. Just recognize it right now. Don't worry about memorizing it. Just because I don't want you to be overwhelmed. Because the moment you think of it as something super big and complicated, you're going to start turning yourself off to the idea of trying to learn it or use it. So don't get overwhelmed by it. Just recognize that this is what it is, and I'm going to walk you through the steps. Okay, so it's not a big formula. It is what it is. Just like any other tool, just like a wrench, just like a sawzall. They all have different functions. They all look a little bit different. They're not complicated. You just need to understand how to use them. So -b plus minus the square root of b squared minus 4ac over 2a. Once again, don't say anything in your head like, oh my goodness, that's complicated, that's big. I'll show you how to use it. Okay, so as you can see, we've got some functions going on here, but what your eye may be caught to are these letters. And these letters correspond to the coefficients of our trinomial. Okay, so if you've already asked these questions, then you already know what each of these letters represent. So what do we do when we want to replace letters with numbers? We use substitution. So that's exactly what we're going to do here. New slide. Okay, so let's do substitution. So the first one we see is B. So remember, when we substitute, we're going to use parentheses because we're not replacing negative b with the coefficient. We're just replacing the b. So this negative stays here. So just put parentheses where the letters were. So negative, our b is the coefficient on the x term. What's the coefficient on the x? The coefficient is going to be this -5. It includes the sign before. So -5. That's why we need to be important about using parentheses, because if you did not substitute this properly, you would have gotten the wrong sign. So keep an eye on that. All right, plus minus, I'll explain the plus minus later. Don't worry about that. It's the square root of b. We already know what b is, -5. And the square goes on the outside because we're only replacing the b. The non-b part stays the same, okay? Very important you get that right. Otherwise, once again, you'll get the wrong sign. -4. A is the coefficient on the x squared, which is just 1. C is the constant, which is -14. Okay, and now 2a. 2 and a is just 1. All right, good. That's the first part, just substitution. Now we can start simplifying. So let's just remember when we have a fraction bar, we can just treat each of these independently. So the top, let's just work on the top. -5 is just going to be +5. Plus minus, and let's do everything inside the square root. -5 squared means -5 multiplied by itself twice. -5 times -5 is 25. Minus 4 times 1 times -14. Well, it's -4 times 1 times -14. The negatives cancel. So really we're just looking at 4 times 14, which equals 56, I believe. +56 because our negatives cancel. Does that sound right? Yes, yes it does. All right. And then 2 times 1 is just 2. All right, we can simplify one more time in the parentheses here. Let's go ahead and bring it up. We've got 5 plus minus the square root. 25 plus 56 is 81 over 2. Okay, square root of 81 is going to be 9 over 2. All right, so we've simplified as much as we can. This plus minus means we're going to do two different things. We're going to do one where we're adding, so 5 plus 9 divided by 2, and then one where we're subtracting, 5 minus 9 divided by 2. Okay, 5 plus 9 is 14 over 2. 14 divided by 2 is 7, and then over here 5 minus 9 is -4. -4 divided by 2 is -2. All right, so we've got 7 and -2. All right, now remember the whole point of this was to figure out how we can turn x squared minus 5x minus 14 into two things being multiplied together. So x plus something, and times x plus something else. All right. So right here, this tells us that one of our x's equals 7 and one of them equals -2. So we can replace that with 7. Oh, I don't want to skip steps. That's a no-no. All right. So we're going to replace one of these with 7 plus something, and one of these with -2. And we want to know what plus 7 equals 0. Or 7 plus what equals 0. So we know that 7 plus negative 7 equals 0. All right, 7 plus negative 7 equals 0. And we know that negative 2 plus 2 equals 0. So this is really what we were looking for. We were looking for what is this part right here? Because that tells us, those are the mystery things we were looking for. So this tells us that x minus 7 times x plus 2 is what gives us x squared minus 5x minus 14. And if we wanted to FOIL that to check it out, we would see that that is correct. Now, I know I may have lost you on this last step. That's okay, because we're going to do a few more practices. And also, I'm still figuring out how to teach everything in the best way possible, so it's going to take a few runs for me anyway. But the first ones are always just to introduce you to the concept and to show you the general flow. We'll do a few more examples. All right, let's use another trinomial we had before. And remember, the goal is to figure out x plus what times x plus what is going to equal this trinomial. All right, that's the whole point of this. Okay, so we have our tool. We have the quadratic equation, which is negative b plus minus the square root of b squared minus 4ac divided by 2a. And we want to do substitutions, and we need to remember what each letter asks. B asks, what's the coefficient on x? Negative 7 plus minus the square root of what's the coefficient on x? Negative 7 squared minus 4. What's the coefficient on x squared? 1. What's the coefficient, excuse me, on, what's the constant term? 12. All right, over 2 times what's the coefficient on x squared? 1. All right, so let's start simplifying everything. Negative 7 is positive 7 plus minus. Let's do the stuff inside the parentheses. Negative 7 times negative 7 is 49. Negative 4 times 12 is negative 48. Over 2 times 1 is 2. All right. Rewrite everything. Let's simplify the square root. 49 minus 48 is 1 over 2. Square root of 1 is 1. 7 plus minus 1 over 2. And now we split into two groups. 7 plus 1 over 2 and 7 minus 1 over 2. 7 plus 1 is 8. 8 divided by 2 is 4. 7 minus 1 is 6. 6 divided by 2 is 3. So that tells us that one of these is 3, one of these is 4. So 3 minus what equals 0, or 3 plus what equals 0? 3 plus negative 3, right here. And then it says 4 plus what is 0? 4 plus negative 4 gives us 0. So we can see that factoring out this trinomial gives us these two binomials. Okay, I think I'm going to stop there. This is a part 1. I will make a couple more parts. That way we can get comfortable with doing this. Okay, bye.